Okay, but look at example 2. It asks us for the value of x in the following figure. Now I want to mention something to you real quick. Notice these two sides are marked parallel. This one is not marked parallel. So if this were a problem involving y, I can't make the assumption right off the bat that y is parallel to z in 30. All right? But just on that note, because maybe on your practice problem in the back you have to find y, let's take a look at y real quick before we get into x. Okay, I just mentioned the side splitter theorem, right? It says if these are parallel, then these pieces are proportional to those pieces. And notice we have all four numbers there, right? The converse to the side splitter theorem is also a theorem. So if there's a proportionality between these sides, we can assume these lines to be parallel. All right? So if I take a look at these sides here, I got 12 over 4. Over there I got 9 over 3. What does 12 over 4 reduce to? 3 over 1 and 9 over 3? 3 over 1. So since the pieces of the sides in this picture have a common ratio, they're proportional, that tells me that this also is parallel to the other two. So keep in mind the side splitter theorem goes both ways. If you have the parallel lines, you get the proportion. If the proportions create equal fractions, then you have parallel lines. All right, so I just want to bring that to your attention in case you had a problem happening like that in homework. It doesn't specifically happen in what we're supposed to do in this problem. Now, looking at this picture, what's the value of x and PQR? Well, if you take a look, this segment here, ST, is parallel to the base of this triangle. So if I'm applying the side splitter theorem involving this whole piece here, which would be 16, and this whole piece here, which would be 12, should be proportional to this piece here, which is x plus 2, and this piece here, which is x. Again, that's where the parallel line is. That's where the side's getting split, right at this point S, right at that point T. So the part above S over the part below S equals the part above T over the part below T. So it looks like this. 16 over x plus 2 should equal 12 over x. Again, 16 is how much there is above S, and x plus 2 is how much is below S. 12 is how much is above T, and x is how much is below T. Okay, so again, with the side splitter theorem, you see your parallel lines in this triangle picture. S and T are the points of interest. Above and below is what goes in the proportion over there. 4 plus 12 is 16, not just 4 or just 12. All right. Once I get to this point, something happens a lot, more and more often as we continue on in the book. We're going to have a binomial structure in this proportion. When I cross multiply, I have to cross multiply following the rules of algebra. So when I multiply this product, 16 times x, nothing weird happens there, 16 times x. When I do this product here, I'm multiplying 12, not times x or 2, but by the entire expression x plus 2. It's not 12 times x or 12 times 2, it's 12 times both pieces. So the distributive property says that this product happens and that product happens. Both numbers get equally multiplied by 12. Anytime you have a sum or difference multiplied by one thing, we distribute that one thing through. So that leaves me on the left-hand side with 16x as it is, and on the right-hand side, 12 times x is 12x. 12 times positive 2 is positive 24. So 16x equals 12x plus 24. That's the simplified expression, simplified equation. Now it's a matter of solving the equation. X on one side, so I'm going to chop positive 12x. Move it over to the left, becomes negative 12x. And if 4x equals 24, we divide both sides by 4, leaving me with x equals 6. What is the value of x? X equals 6, that's the answer to the question. Keep in mind, once we know x equals 6, now we know PS equals 8. And RT is equal to 6. All right? if I'm attempting to find y or z at this point, I have to use similar triangles. There's no side splitter theorem for the bases. So find your similar angles, or your same angles. This angle matches that angle, matches that angle. This angle matches that angle, matches that angle. This angle up top is one of all three of the triangles in the picture. So we use similar triangle proportions to find the missing y or z value at that point. All right?